Welcome back, ladies and gentlemen. Today I wanted to share with you a few techniques that are associated with just a calculator on how you can help you use your calculator to do some calculus or calculus related tasks without too much strain. So if you want to follow along, grab your calculator, and the first thing I'm going to ask you to do is follow this exact key sequence. Go second plus sign 712, and you can notice that this emulator is kicking out the key sequences that I'm typing in right here exactly. And what this should do is this should clear the memory on your calculator. It will erase all programs, it'll erase all stats, it'll get you in default modes, basically sets it back to default mode from the factory. You'll notice that if I click on any of these things, everything's empty and we're ready to go again with a blank slate. So the first thing I'd like you to do is I'd like you to go ahead and go up into y equals, and I want you to type in this function just so we can look at the same function altogether. 1/3 t, or x to the third power. If you are working with a function that has a t in it, you can replace that with an x in order to graph it. Let me just type this in, minus x squared minus 3x plus 8. I'm using functions that are on the note guide for 2.5 that you can find on Schoology. So if you want to look at a visual representation of the same function, you can follow along with that worksheet as well. The first task that I want to talk about is how to evaluate a function. And there are many ways to do this. You might know that if you go to your table will generate a list of x and y values. Now, in the default factory setting modes, it's going to do that starting at a x value of 0 and increasing by 1, and it is going to generate both the x and y's for you. If you'd like to change any of those settings, you can go into the table set feature, and you can see this is above the window. It's a second feature, and you can see that it is saying where the table starts at 0 and by how much it's going up by. And you can control both of those. If you'd like your table to start at 2 and go up by increments of like 0.2, and then go back to your table, you'll notice that your table is now starts at 2 and goes up by increments of 0.2. I think a table is most effective though when you talk about changing the independent variable to the ask setting. So if you go back to the table now, it will be entirely blank once you go to the table. Let's go table. Okay, there we go. Okay, it's just froze on me a little bit here. Wait for it. There we go. Now we're back at the table, and now it is asking you for the x coordinates that are associated, whichever x coordinates you want. So anything under the sun that you so desire. If you type in 1.52, hit enter, it's going to use that as an x value. It's going to plug it into the function that's under y1, and it's going to give you a readout in the table. Now there's a cautionary tale right here, is that the table only reads to 4 digits, but you can see that if I just arrow over and highlight that cell, you can see the full approximation of that decimal to like 11 places or something like that. Just be aware that the table truncates those values, and you probably do not want to round or truncate any of those numbers if you're working with, if you're not done with the problem. You only want to round the problem at the end. Okay, I'm going to stop showing the key sequence here. I'm going to switch over to the live screen so that larger screen so you can see what's going on a little bit better in the video. I'll probably switch between those two items. The second way that you can go for a specific function value is if you go to the graph of the function itself. There is a trace button right up the top 5 buttons associated with the graphing features, and you notice that if you hit the trace feature, you get the little spider that crawls along the graph for you. It's a little cursor that does that. Now notice that it goes pixel by pixel, and some of those pixels are probably not x values or y values that you're very interested in. So if, for instance, you want the x value of exactly 1.5, you can just go ahead and hit 1.5, hit enter, and then it will read out both the x coordinate and the y coordinate on the screen. Furthermore, almost any time that you ask the calculator to calculate either an x value or a y value, it'll actually store those values in the alpha characters x and y. So for instance, if I go back to the home screen right here and I just type the x, you'll notice that it is equal to 1.5. That's the value that we just entered. And if I go for alpha y here, if I can find it quickly, there it is. You'll notice that it also stored the value of 2.375. So these values are stored for you for later use, which is really nice when you're dealing with really long, nasty decimals and you you're worried about accuracy in your final answer and you don't want to round. So they're stored for you. If you would like to, now every time that it calculates an X and a Y value, it's going to overwrite these values. So if you would like to store any of these values under a new character, you are more than welcome to using the store key. So you can hit the store key just above the on button, and you can store it under any alpha character of your choice. And so this is storing the value of 2.375 into A, and anytime you use the letter A in the screen now, it's going to think of that as 2.75. And you can even do calculations with it as a variable. So 3 times 2.375 is 7.125. The next way that you can calculate a function value is actually my personal favorite, and it has to do with this button down here, the variable button, and it's not a button that a lot of people know about. So go ahead and click on it, and we're going to scoot over to the right under Y variables, and we are going to choose functions from that list. And now you'll see a list of all the functions Y1 through Y, I think 10, and they relate to the same Y1 through Y10 that you're allowed to plot under Y equals. Now, if you go ahead and select one of these on the main screen, that's going to be the representation of the function, and it's kind of like function notation. If you'd like to evaluate it at 1.5, you insert parentheses and you type the value 1.5, and it'll kick out the function's value at an X value of 1.5, and you can continue doing that with whatever X value of your choice. So if you wanted to scoot that over to 2.5 instead, well, as long as you don't make a typo, you can do that. So if we do that, well, that's just, we're just going to be done with that, but you get the idea. The next thing I want to talk about Zoom. Okay, there's a lot of stuff in Zoom that we just need to know how to use so that we can look at functions in a more meaningful way and make sure that we're accurate about it. So the first thing I want to talk about is zooming in and zooming out. If you know how to do this, you can skip over a little bit, but I still get a lot of students that don't know how to zoom in and zoom out on a graph, so I'm going to demonstrate how to do that. I'm going to zoom in. And the interesting thing about the zoom feature on these graphs is that you'll get a little cursor, and wherever that cursor is, will be the new center of the viewing area. So if you'd like to zoom in on this local minimum right here, it'll center the screen around where that cursor was, and it will zoom in. It will not zoom in until you hit enter. I think that's what a lot of students expect. They expect, oh, I just selected zoom in. Why isn't it zooming in? Well, it's because you didn't actually execute the zoom in feature. But once you hit enter, it will zoom in on the specified area. And if you continue to hit enter, it will continue to zoom in on the specified area until it can no longer calculate the values. So if you want to zoom out, you can do the same thing. So select the zoom out, but I actually don't even do that. The biggest, most important thing under the zoom menu that you probably need to know is zoom standard, and that gives you the standard -10 to +10 viewing window on the x-axis and the y-axis. So it's a 20 by 20 window, and if you go zoom 6, you can either hit the zoom button and the actual number 6, or you can arrow down to the 6th option and hit enter. That will give you your standard 6 by 6 viewing window. So if you happen to screw up one of your windows, you get this error called invalid dimensions. So if that's happening to you, just go back to normal, go back to zoom 6 and work yourself from there. Also inside of the zoom, there's a couple other things. There's a zoom box where you're allowed to draw a box around whatever you want your new window to be. There is zoom decimal. What this does, very interesting, so if you notice when we traced the graph, our cursor fell across X values that weren't necessarily very nice values, because the 20 units long of the x-axis is divided by however many pixels are there, and so you get this nasty fraction decimal right there. If we switch to zoom decimal, the pixels become much nicer numbers. I'm not sure exactly what the rules are. I think it's by tenths, but now you can see if we trace the function, you can see that the X values are going up by 0.1 each time. So I believe that's what it does, always 0.1. The other feature in here that's kind of interesting is zoom square. And what this does is you may notice that the screen is a little bit wider than it is tall. So it's got an aspect ratio of about 4:3. And what so if you were to view a circle, it would actually look like an oval because it's being stretched out left to right a little bit, or squashed top to bottom, whichever you want to think about it. What zoom square does is it makes each pixel the same length on the height and on the width of the pixel. So when you look at a circle on the screen, it looks like a circle now instead of an oval. And it's also handy for things like, when you're looking at the line y equals x, well, that's got a slope of 1, so it should appear on the screen like a 45-degree angle. When you do that on the standard viewing window, it doesn't actually look like that. So if you do zoom square, it will make the line y equals x look like a perfect 45-degree angle. The last one that I want to pay attention to in the zoom menu is zoom trig, and as you might suspect, that's a really nice window for your doing trig functions. I believe the window is from negative 2 pi to positive 2 pi with increments of pi over 4 or something like that. So it's nice to work with. It's nice to work with that zoom feature when you're dealing with trig functions. Okay, I'm going to revert back to Zoom 6 here, and I'm going to look at that function that we had typed in. And now I want to move over to this calculate menu, which is above trace. And there's a whole bunch of things in this menu, and we're going to go through most of them here and show you how they all work. You need to know, right now you need to know everything except number 7. That's an integral. We'll deal with that later on in the year. But you'll notice that number 6 does say dy dx. And yes, your calculator can calculate derivatives for you, both at a point and for all x. But I wanted to show you a few other features in this menu, and we'll finish with the derivative. First one up on the screen is actually how to calculate a value of the function. So this is a lot like a table or a trace feature. And again, you just type in whatever x value you want. It's going to put the cursor there. It's going to highlight the y value. The second thing on the menu is a 0. So if you look at our graph, you notice that there are 3 zeros that we should be able to find by using this calculate feature. So if we go to that calculate feature and we select 0, now we have to be a little bit smarter about things. Okay, what it's going to ask for, it's going to say, hey, please give me an interval on which to search for this 0. What the calculator is going to do is it's going to go pixel by pixel and look for a sign change. In this case, from positive to negative, we're going to find that 0 that's close to the cursor right there. So the information that we feed to the calculator has to be a left bound, that is a left bound for the searching of the interval, and a right bound, that is a right bound for the interval. So I just want to make sure that I'm to the left of the 0 a little bit, and I can do that with the left and right arrows. Then hit enter. Then it's going to ask you for a right bound, so I'm going to go a little bit to the right of that 0, not to the next 0 over, because it'll go find one of them, but kind of randomly. And then so I'm a little bit to the right of it. I'm going to hit enter again, and then it's going to ask you a third question, which is guess. So get the cursor close-ish to where you think the 0 is. And the reason for that is, occasionally some of these functions can be very complicated and they can take actually a long time to even plot. So when you're asking to find a sign change between pixels, sometimes it's a lot of work for the calculator and it just takes a long time. So the closer you are with that guess, the faster it will turn up a result. So if you hit enter one more time, it will read out the x value and the y value. And again, it just calculated an x value and a y value. These x values and y values are now stored under x and y, just as a side note. So if you need to use that in a further calculation, it is stored for you under the variable x, which is kind of cool. Let's continue on down the calculate feature. There's some features that are very similar to finding a 0. So if we wanted to find a minimum, where that minimum is, it's going to ask you the same set of 3 questions. So slightly left of the minimum, hit enter, scroll over to your slightly left or slightly right of the minimum, and then you're going to want to guess where about that minimum is. Hit enter one more time. And here's an excellent example of where you might want to try to be a little bit smarter than the calculator. You'll notice that it read out the minimum occurs at 2.999999984. Okay, I think what it meant to say was 3. Okay, I would bet that the real answer to that is that there is a minimum at 3, and understand that what your calculator is doing is an approximation. It is not exact. It is a very good approximation, but understand that it is doing an estimate to some extent. So there's a great example of where you might want to override your calculator and just say that, yes, I am indeed smarter than a calculator, and the answer is 3. Next up on the calculate feature is a maximum, which works the same way. The next one is an intersect. Okay, this is an extremely powerful item. Okay, so it's something that students don't use very much, and I think it's underutilized. So you have solved a lot of equations in your day, and this is a visual way to solve any equation whatsoever. So I'm going to go back to y equals, and let's say that we had this cubic function that we've already typed in. Let's say that the problem said solve for x, and the other side of the equation was 8 minus x. Now, if I asked you to solve the equation 8 minus x equals this giant cubic thing, that is a bad day. You're not going to have any fun solving for x on that occasion. But graph them. And you'll notice that the linear line crosses the cubic line 3 times. Where the line crosses the cubic function, the function's values are equal. In other words, at those x values, it satisfies the equation. So if we can find the intersection, or at least just the x value of that intersection, we can literally solve the equation through a visual means. So if you go to second, calculate, and this time now go to intersect, or select the option 5, and we're going to go find this intersection, and the answer to this, the x value of this intersection, is solving that equation for the value of x. And you notice there are 3 intersections, so I'd have to do this to all 3 of them. I won't do that in this video. To answer that question, you'd have to do it to all 3. But it's going to ask you 3 questions again. It's going to ask you, am I on the correct curve? Am I talking about curve 1? And you can say yes, because you might have like 5 things plotted, not just 2. So am I on the first curve? Yes. Am I on the second curve? You'll notice that it changed over to the linear function, which it did. And if you want to cycle through which curve it's on, you can hit the up and down arrows to change functions. But now it's on the second curve. That's great. And then you want to scoot over towards, and again, take a guess of about where it is. And once it does that, it's going to kick out both an x value and a y value of where that intersection is. So the answer to the solve this equation for x, one of your 3 answers would be 4.372. And just for convenience sake, it has stored that again under the variable x and y, should you need that any further. Okay, now to the fun part. We actually haven't done any calculus yet. So let me show you how to do a little bit of calculus. If we would like to calculate the slope of a curve at a point, we can do that using option 6 here. I'm going to go back to y equals, and I'm going to clear out this linear function because I just want this to be slightly cleaner. All right, so it's going to take a little while to graph here, but we will go back into the calculate menu. We will select option 6, and it only needs an x value. That's all it needs in order to do that. So I'm going to type in x value 3.5. Okay, and it will read out, depending on which calculator you have, it will read out that the slope is 2.25, and I'm betting it's just plain old 2.25 at an x value of 3.5. So if we wanted to, we could write the equation for a tangent line doing that. I want to show you one other place that you can calculate a derivative for a specific point, and that you can actually do it from the main screen. Under the math menu, which is just south of alpha there, so if you hit math, you'll find down here, I believe it's option 8, so you got to scroll down a little bit, at least on this calculator you do. I believe this emulator is older than a lot of the other calculators that you're actually holding in your hand. And here's where I have to talk about MathPrint a little bit. Okay, so there is a feature on modern calculators. If you go into mode, you're going to see something that says MathPrint somewhere, either at right at the top of the first page or the top of the second page. And what MathPrint is the ability for a calculator to display superscript and subscript information and just do pixel sort of formatted text. Okay, this emulator right here and older calculators, 83s and some 84s, are on a text-based system, so it's much more like just like straight up writing code. So if you want to follow along with me, I need you to turn MathPrint to classic mode, and I can't demonstrate that on this screen because I don't have MathPrint versus classic mode even as an option on here. So if you would turn it onto classic mode and then go back to that math menu and select option 8, and you will see the exact same thing that I had. If you don't have it in classic mode, it's going to be actually a lot easier, but I just want to explain how you do it in classic mode because it's what will be cited in a textbook most likely. Okay, so the end-derive function on this requires 3 inputs from you. It needs to know what function you're talking about, which variable you want to take the derivative with respect to, and where you want to take that derivative. So first one, we want to take the derivative of y1. So I'm going to go to y variables again, go to functions, select option 1. So I'm going to take the derivative of the cubic function that we have stored in y1. I would like that to take that with respect to x. So again, and then I would like to take the derivative at 3.5. Okay, and that represents the slope. We should get that 2.25 answer, and we do. I'm going to store that in the alpha variable m, because my next job, I want to go plot a tangent line on this graph to show you how that's done. And you can do it all without actually typing in any numbers. You can just type in what it should calculate and do it for you. Okay, so here's a great way to calculate the derivative of a function without having to access the graph. So maybe you wanted to calculate the derivative at 310.2, and that's way off of the viewing window, and you don't want to mess with that. Here you can do that. So that's an option. Now let's graph a tangent line. So let's go back up to y equals, and there's a cubic function, and we would like to graph the tangent line, and we might as well do it at 3.5 because that's where we've been talking about. Now, there's two ways I could do this. Remember, I stored that slope in the variable m, so I can actually just type m, and that's my slope. And I'm going to use point slope form here. Point slope form usually has a y value being subtracted on the left side. I'm going to add that to both sides of the equation and bring it over to the right here, and you'll see what I mean in just a moment. Now I can hit x minus, and the x value that we're doing the tangent line at is at 3.5, and then I'm going to add the function's value at 3.5. So this is our y1 value. I can do that without having to calculate anything using the variable feature here. So I can do y1, and I can use that function notation sort of deal right there. So what that's going to do is going to evaluate y1 at 3.5. So I have my x1, y1, and I have my slope. And if I hit graph there, it might take a little while, but it should come up and kiss the graph in exactly one place and continue on its merry way, which it looks like it did. Okay, so what I want in terms of calculus from you today is I would like you to know how to do a linear approximation. So here we have a curvy graph and we have a tangent line. And you notice that near the point of tangency, the tangent line and the curve itself kind of squished together, and they're basically the same thing. In fact, if we took time to maybe zoom in on the function near that tangent line, so I'm going to move my cursor over here, we can see a little bit more about what's going on here because it is highly pixelated on this screen right here. If I zoom in, we might be able to see a better picture of what's going on. And what linear approximation is it's a technique used to estimate the value of the curve near a point of tangency, but using the tangent line instead of the function. Maybe the function is way too complicated to evaluate. Maybe you don't have a calculator, but you can evaluate what's on the tangent. Maybe the function has some issues over to the right of it. Okay, so like we just did a tangent line at 3.5, which is right about there. If we wanted to estimate what the function's value was at 3.6, now all we need to use is type in 3.6 to our tangent line. Okay, so if we go back to y equals, you understand that we got our tangent line in y2 and our original function in y1. So if the problem that you were tasked with said, please estimate the value of the curve using the tangent line or using a linear approximation, then you can basically just, the shortcut is to use that y variable notation again. And this time, instead of y1, our tangent line is in under y2 in this calculator. So I can hit enter, and if I wanted to estimate a point near 3.5 but not 3.5, so maybe the question asked you to estimate 3.6, all right, that will be the tangent line's function's value at 3.6. And if you didn't know the function's value, you would know that that is a very good estimate of that. We can check to see how accurate our tangent line approximation is by, in this case, we know the function, so we can actually just calculate the function, the original function itself, at 3.6, and this should be a very close number to negative 0.233, and you can see that it is. So that's what's called a tangent line approximation. We've found a very near value to the actual value by using the tangent line instead of the actual curve. Through these processes and with these little shortcuts and little codes that I've shown you today, hopefully this has shown you a few ways to get your work done in a little bit more efficient manner should a calculator be available to you. That's all I have for you today. I'll see you next time.